Your attention on the board then. So, we're going to have a quick look at something called completing the square. Okay, it's not that hard, but a lot of people treat it as quite difficult. It's really not. Okay, so I hope I'll talk you through it in a relatively intuitive way. Could you expand this out for me?
X squared.
X squared plus 2x plus 1.
Perfect. Well done. What about this one?
X squared plus 6x plus 3 times 9.
Good. Well done. What about this one?
X squared negative 8x and 16.
Good. Well done. Now, what do you notice about all of these three quadratics? So when you factorise them, ordinarily, if I gave you something like this, for example, and if I asked you to factorise this, what would this become?
X plus 2 times x plus 1.
Okay. So what I'm trying to show you is that if you start with something like this and you factorise it, in general, if it can be factorised, it'll be factorised to something which has two different factors. Okay. But what about all of these quadratics? What do they get factorised to?
Same factor.
The same factor, right? Because x plus 1 all squared literally means x plus 1 times x plus 1. Okay? Now we give that a special name. So when we have a quadratic that can be factorised to something which just has one factor, squared, okay, we call all of these perfect squares. And if you think about it, that's because if you factorise this, you can think about this in terms of the square which I gave you like this. So this one here, for example, x squared plus 2x plus 1, that's the area of this square, and the side length is x plus 1. Is that okay? Yeah? So all of these things can be factorised to a perfect square rather than, say, to a rectangle. Is that okay? Yeah? So perfect squares are really nice. Perfect squares are really nice. Now, what I'm trying to say is not everything is a perfect square, but can we make it look like a perfect square? For example, take something like this. X squared plus 2x plus 4. This isn't a perfect square, but we can make it look like a perfect square. So how?
2 times 2.
We can I don't know how to say it, but
Okay.
then we can turn 4 into 1 plus 3.
Good, and you want that because you're going, hang on a minute, this looks suspiciously like this. Okay, which I know this is definitely a perfect square. Okay, we'll discuss what makes a perfect square later on, but this is definitely a perfect square. This looks suspiciously like this. The only issue is this plus 4. Okay, if this was a plus 1, we'd be in business. But that's okay. I can turn a 4 into a 1. I'm a magician. I can go that is just the same as 1 plus 3. Is that okay? Yeah, 1 plus 3 is still 4?
Yep.
Yeah? And I go, okay, that bit there then, that bit there is definitely a perfect square. What would it be?
X plus 1 squared.
I just have the plus 3. Okay?
So what do we do with the 3?
The 3 is still there. There's nothing we can do with the 3. But my question is, why is this a useful form? So remember what I started with? X squared plus 2x plus 4. Okay? Why is this more useful than this?
Because it simplifies it.
Does it? I mean, there's definitely more things going on here. Anybody think, why is it more preferable to leave it like this rather than like this? Sketching the graph. You remember where we started with quadratics last Tuesday? I said, if I give you something like this, y equals x plus 1 all squared plus 3.
I mean, we move it to the right or up?
You tell me.
To the right?
No.
To the up.
So the plus 1 moves it to the left by 1, and the plus 3 moves it up by 3. Yeah? So this is a really useful form for working out the sketches, like the translations from the original y equals x squared. And I said to you last Tuesday, we will look at going from here to here. We've just done it. Okay? The idea is that you need to make it look like a perfect square. Now, I've kind of given you kind of a don't know, holistic way of looking at this. Let's look at this in a bit more detail. Let's actually realise how we can get this x plus 1 all squared from that thing. Okay, so let's look at these. What do you notice about this 1? Where is it buried in this x squared plus 2x plus 1? Let's have a look. So I'm looking at the plus 1, looking at the plus 1. Do you notice there's a relationship between this number and this number? What's half of 2? It's 1. What's 1 squared? It's 1, right? So what I'm saying is, if you halve that number, you get 1. And then if you square whatever you get, you should get that number. So halve it, square it. Let's see if the pattern still continues. Okay. What's half of 6?
3.
Okay, so that's looking good. What's 3 squared?
9.
Okay, so that notice it still works. Let's just check the last one. What's half of negative 8?
Negative 4.
Negative 4. What's negative 4 squared?
16.
16. Now you notice there that even though it was a negative, it still came out as a positive over there. Do you see that? Yeah? So regardless of whether it's positive or negative in here, it would always be positive over there. Okay? So I wonder if you could factorise this thing. What would this thing be? So let's think about it. What's half of 10?
5.
Okay, so you're saying it should be x plus 5 all squared. Let's check it. What's 5 squared?
25.
25, so it looks like it should work. Okay, what about this thing? What should go here?
8.
Careful. Should be negative 8, right? Because half of negative 16. What's negative 8 squared?
Negative 64.
64. So it looks like it should work. So my rule is, halve this thing, that will give you the number goes there, and then just check it. If you square it, it should go here. Now, let me try and show you this in a little bit more. Let's imagine we didn't know this. Okay, so get rid of this, get rid of this, get rid of all of this. Now we've got that pattern of halving and squaring, it should be relatively straightforward from this point in. So what I'm saying is, the only two terms that I really care about are these ones. Okay? I don't care about the plus 4 at this stage. I can always just adapt it later. So I'm looking at that, and I'm going, okay, if I was going to factorise this to a perfect square, I'd be looking at that 2x term. Would you be happy with that? Now, if I was going to factorise this to a perfect square, what would it become?
X plus 2.
X plus
1.
1. You make sure you square this, right? Now, if you, sorry, you need to halve this. If you square this, what do you get?
X squared plus 2x plus 1.
Yeah, so if you expand this out, you get x squared plus 2x plus 1. I don't want the plus 1 there. Remember, I just want the x squared plus the 2x. Okay?
So minus.
So I'm going to take away 1. And the plus 4 just comes along to the right. Is that okay? And I can tidy this up by going, okay, this is just x plus 1, all squared, but minus 1 plus 4 is positive 3. Let me do another one. Let's take some of this. Okay? Now all I'm interested in are these first two terms here. The x squared plus the 4x. The minus 2 comes along to the right. In fact, let me write the minus 2 in now. I don't care about it. Just pretend it's not there.
X plus 2.
Good. So you're looking at this x squared plus 4x. You're saying halve the 4 to make it x plus 2, all squared. But the only trouble is that if I expand it out, it's going to have a plus 4 on the end. I don't want the plus 4. So I'm going to take it away. Okay?
We need minus 6.
Good. Is that okay? Let me do another one. What about x squared minus 10x plus 5? Okay. So just look at the first two terms, that's all I care about. What would that be if I was going to try and perfect square it up? Good. But what do I have to take away? 25, right? I have to take away 25 because I don't want that plus 5 squared, or negative 5 squared. And the plus 5 just comes along to the right. Is that okay? So in total I'll just end up with x minus 5, all squared, minus 20. Do you see that? you have a go at this one. Look at that.